Hello students, this is one of the beautiful problem that has been given in JEE Advanced 2025 paper number 1. The question here it says, let n denotes the set of natural numbers and z denotes the set of all integers. Consider the function f that is defined from natural numbers to integers and g is a function defined from integers to natural numbers. Now f of n is been given as a function that has been defined piecewise for n as an odd function and for n as an even function, and g of x or g of n is again a piecewise function that has been defined for n greater than or equal to 0 and for n less than 0. Now fog and goff is the composition of the functions f and g, and we need to comment on that which of the following options is or are true. So we will just analyze both the functions one by one. Now analyzing the function f of n. Now f of n, as we can see, is been mentioned as n plus 1 by 2 if n is odd. So we can take the number n as of the format of 2k plus 1. So I will just rewrite this function as f of n, which will be equal to, this is n plus 1 divided by 2, and this is when n is equal to 2k plus 1, and this function will be 4 minus n divided by 2 if the value of n is equal to 2k. Or else this we can write it as that this if n is equal to 2k plus 1, then we can write the value of k is going to be equal to n minus 1 by 2, and substituting the values back into the function. So we can see that the function will become equal to k plus 1. This is when if k belongs to the natural numbers union with 0, and this is 2 minus k, this is when k belongs to the natural number. Now we can clearly see from here that for k is equal to 0, we can see f of 1, we are getting it as equal to 1, and which will also be equal to f of 2. So for two distinct values of k, or for the two distinct values of n, we are getting the same value. So this simply implies that f of x or f of n is not a 1-1 function, not a 1-1 function. So we can see that f of x is not a 1-1 function, so that has been given in option number D. We need to check for whether the function f of x is onto or not. So we can see here that k2 minus k, for k belonging to natural numbers, it can cover all the negative integral values, and this k plus 1 for k belonging to natural number union with 0, it can cover all the positive integral values. So this simply implies it can take all the integral values. So we can see that f of n, whatever we are talking about, so that will always gives the answer as a integer, and all the integers will lie into this range. So this simply implies that f of n will be a onto function, so which makes option number D as the correct one. Now similarly we can analyze the function g of n. Now g of n, directly we can see that this is 3 plus 2n if n is greater than or equal to 0, and this is minus 2n if n is less than 0. Now this function has been defined for integers to natural numbers. So if I am going to substitute the values of integers over here, so for n greater than 0 or greater than or equal to 0, so we can take from the first branch, we can get the set of numbers as 3, 5, then 7 and so on. And for n less than 0, we can start with n is equal to minus 1, so we are getting the values as 2, then 4, then 6 and so on. So clearly we can see that one of the element, that is 1, is been missing over here. So we can see that function g of x will be a into function. So g of x is a into function. Or moreover, we can talk about the g of x function. So g of x function will be a 1-1 function because it can take all the values, that is 2, 4, 6 exactly one time. So g of x is a 1-1 function, but it's not an into function. So this implies the third option is wrong. Now we need to comment on the two different functions, that is fog of x and goff of x, means f of g of x or g of f of x. So starting with g of f of x or g of f of n. So wherever we have x in g of x, we will just replace that with f of n. So this is going to be equal to 3 plus 2 times of f of n. This is when f of n is going to be greater than or equal to 0, and this is minus 2 times of f of n when f of n is less than 0. Now substituting the values, so this is going to be equal to this is 3 plus 2 times of n plus 1 divided by 2. This is when n is equal to 2k plus 1, and this is 3 plus 2 times of 4 minus n divided by 2. This is when n is equal to 2k. So g of f of x we are going to get over here as n plus 4, and this is 7 minus n, and this is for n is equal to 2k plus 1, and this is for n is equal to 2k. So we got a function g of f of x. So we can see from here that g of x or g of f of n, this will always gives a odd value, and this simply implies this is not a onto function. So gof is not a onto function, this is matching. Now gof is whether 1 1 or not, then we can see that if I'm going to substitute any values over here, so that values is going to repeat. Like as an example, g of f of 1, so this value is 5, and this is also equal to g of f of 2. So this simply implies that the function is a many one function. So this makes option number A also as the correct one. Now we need to check for the last part, that is f of g of n. So f of g of n, that is going to be equal to g of n plus 1 divided by 2, and this is 4 minus g of n divided by 2, and this is when g of n belongs to the odd natural number and g of n belongs to the even natural number. So in both the cases we can see that this is n plus 2, and this is again n plus 2. This is for n greater than or equal to 0, and this for n less than 0. So this function we are going to get it as n plus 2, so for all n. So this simply implies that g of f or f of g of x, this will be a 1 1 function, but here they mentioned it's a not 1 1 function. So this makes option number B also as the incorrect one. So we got the correct answers as A and D. So let's verify. Yes, A and D is the correct answer. Thank you.